Here we've been presented with a situation where we've got an unidentified compound, and we've been told that it contains bromine and fluorine, and we've been given the percentages by mass within this compound. So how am I going to approach this? Well, we've been given the percentages by mass, right? So one of the first things I'm going to do is I'm going to just have a look and see, well, if I add those percentages up, what number do I get, right? It might be 100, it might be something else, so but I'm going to check, right? So 45.68 plus 54.32. And so if you have a go, you can see what you get from that, and what you should find is that you get 100 in this case. Okay, so what are we trying to actually get? We're trying to get the empirical formula, which, as we would know, is the simplest whole number ratio between the elements in this particular compound. And this is effectively, it relates to the relative amounts of substance, right? So the relative amounts of substance, and therefore what would be helpful for us to solve this would be to get actually molar comparisons. But in the current format, it's not so easy to do. We've got percentages by mass, right? And given that they've got different relative atomic masses, it's not as straightforward at this stage. But what we can do is we can make an assumption to help solve for this. So the assumption we're going to make is we're going to assume that the sample we've got is a 100 gram sample, right? So we're going to assume that this sample is 100 grams. And by making that assumption, we can then say, okay, well, therefore, for bromine, we've got actually 45.68 grams of bromine. And we can say that for fluorine, we've got 54.32 grams of fluorine. Now, at this stage, what we're going to do is try and convert this to amounts of substance. So effectively, we're going to try and convert it to moles. And how do we do that? Well, as we would know, moles, the relationship between moles and mass is N equals M in grams divided by the molar mass in grams per mole, right? Okay, now we don't have the molar masses given in the question, but we know what elements we're dealing with. So we can refer to the periodic table and find out the relative atomic masses, which in this case would be the molar masses of the elements. And so here you've got the bromine and we've got the fluorine, right? And you can see we've got 79.9 and 19, right? So these are the values I've got them here as well. So if you just now write that out from here, so the MR, so that and this is all MR in grams per mole, right? I mean, that's what's appropriate for our question. So the MR of the fluorine is going to be, as we can see, it's going to be 19. So 19 grams per mole. And the MR of bromine, BR, is going to be, as we see here, it's going to be 79.9, right? And of course this is in grams per mole. So what we can now do is effectively we can use these values and say, okay, well, using the moles equals mass times molar mass equation, we can say, okay, well, divide these by their respective molar masses. So divide this by, in bromine's case, 79.9, fluorine's case, we divide it by 19. And so now, if we work this out, we've got now established effectively the comparison between the actual number, the amount of substance in the form of the comparison between the moles. And so I'd invite you to have a go, calculate this, see what you get, and yeah. Okay, so I'm going to give my own answers to 5 decimal places. So for bromine, what I got was 0.571 0.71, and for fluorine 2.85895. Right. Now what we want to do at this stage is we want to actually establish a whole number ratio, the simplest whole number ratio, which currently we don't have that, right? If we were to round any of these two numbers to, for example, 2 decimal places or even to 1 decimal place, we're not going to get a whole number. We'll still have effectively non-integer value. So, but how can we force at least one of these to be an integer? Well, the way we can do that is by dividing both values by the smallest value, and that's what I'm going to do. So I'm going to divide, as you can see, the molar value associated with bromine is the smaller value, so I'm going to divide both by that. So divide this by 0.57171, which of course would give us 1, and divide this by 0.57171, and so you can have a go work out on your calculator what this is going to be. And if you did that, what you should find is that for this case, of course, I mean, you wouldn't need a calculator on this side, but that would get you a 1, and on this side, this gets you a 5.00070, right? Now, what do we notice here? Well, what we notice is that contrary to what the situation was before, where rounding to 2 decimal places, rounding to 1 decimal place didn't give us an integer value, in this case, if we round to 2 decimal places, we do get an integer value. If we round to 1 decimal place, we do get an integer value. And therefore, what we can say is, in this case, we can say, well, let's round it to even 2 decimal places. You're going to get a 1 here, of course, and we're going to get a 5, right? It's just, now we've got 2 integer values. And we ask ourselves, well, is this our simplest whole number ratio? Well, if you divide the 5 by, I don't know, by 5, you still get a whole number, right? But unfortunately, if you divide the 5 by 5, you have to do the same thing on this side, and 1 divided by 5 is obviously not going to be a whole number, right? So therefore, that wouldn't work. So effectively, this is our simplest whole number ratio, and we can say, well, you know, associated with the BR is going to be a 1, and associated with the fluorine is going to be a 5, right? And on that basis, we can therefore conclude that the empirical formula is going to be BRF5. Okay? So that would be our empirical formula.